We have a new solar storm warning. Earth has been hit hard by huge sun ejection, power and radio warning issued. Earth hit hard by the ejection from the sun, with the solar storm causing radio and GPS interference, as well as aurora dancing over locations including Scotland, Norway, and New Zealand. North and southern northern lights and southern auroras. One of the most powerful forms of solar storm, the coronal mass ejection (CME), occurs when the sun belches clouds of charged particles and electromagnetic fluctuations. This CME, which began striking the Earth yesterday, was released from the sun's surface March 11, some 373 miles per second, accompanied by the flash of solar flare. And according to researchers, it was not the intensity of this emission, but its long duration, which led them to anticipate a moderate geomagnetic storm here on Earth, with energy being expelled into space over a period of 12 hours. And according to U.S. Space Weather Prediction Center, the storm has been classified as a G2 event on the 5-point G scale, which is G1 is the weakest, G5 the most severe. In a post published yesterday, they said disturbed conditions are expected to continue throughout the day and into tomorrow. A G2 storm, the experts say, can cause mild power grid fluctuations, interference with satellite operations in low Earth orbit, and the disruption of high-frequency radio signals at higher altitudes. The latter effect was certainly seen. Space weather expert Dr. Tamitha Skov said in her tweet, "Many reports of impacted amateur radio propagation today." She said the rather sporadic magnetic field in the solar storm is really disrupting the bands. Switching to lower frequencies might help. They are less impacted by solar storms, especially on Earth's night side. The most obvious effect of the CME, however, came in how it boosted the aurora borealis, that's the northern lights, and australis, the southern lights. The natural light shows generated when particles from the solar wind excite atoms in Earth's upper atmosphere, making them glow. The aurora forms curtains of light that follow the geomagnetic field lines of our Earth and appear in different colors depending on which atoms are being excited. The two primary gases in the Earth's atmosphere are oxygen, which emits a greenish light, and nitrogen, which appears in hues of blue, pink, and purple. Dr. Skov highlighted that stunning auroral displays were seen in locations such as Australia, Norway, Scotland, and Sweden. She says, wow, not only has the solar storm arrived early, but its initial impact hit hard enough to cause aurora to brighten to a point that it could compete with the nearly full moon and the brightest lights over Stockholm. And now, according to experts on space weather, the storm is now subsiding, while there is the possibility that conditions could flare up again as the Earth moves through the magnetized wake of the CME, which will likely only reach G1 class conditions. They said auroras will repeat to the Arctic Circle March 14, that's today. Alongside this weekend's enhanced auroral lights, the CME also caused interference with Earth's geomagnetic field. It induced, for example, electric currents within the soil of northern Norway. Citizen scientist Rob Stamps of the Lofoten Island told Space Weather today, March 13, just before 11 o'clock UTC, the expected shockwave arrived on my instruments. He said variations on my magnetometer and ground current instrument. Also a ripple or ionization on my VLF receiver, which is remarkable, he said. Now, while the weekend solar storm was only moderate in intensity, some experts fear the impact that a G5 event might one day have on modern society. A coronal mass ejection is in September 1859. The Carrington event caused the most powerful geomagnetic storm on record, one which scientists referred to that name, Carrington event. The storm affected telegraph networks across Europe and North America, as well as the recently laid transatlantic link that connected them. Currents generated in cables by the space weather at that event reportedly caused telegraph pylons to spark, operators to receive electric shocks, and some lines to fail completely. Other lines in the meantime were found to still operate even once their power had been cut. So strong were the electric currents induced by that storm. And according to the study presented at the Association for Computing Machinery annual SIGCOM conference last year, a large solar storm like the Carrington event could have the potential to cripple the internet for weeks. Unlike Victoria-era telegraph lines, the fiber optic cables that make up the backbone of the internet are actually immune to the electromagnetic fluctuations caused by solar storms, so that's a good thing. The same cannot be said, though, for the single boosters that are dotted along undersea cables in order to maintain connections over long distances. And being underwater, not only are these long-distance cables more vulnerable to the impacts of space weather, but they're also inherently harder to access for repairs. Astrophysicists predict that there is a 1.6 to 12% chance a solar storm powerful enough to cause catastrophic disruption to modern day society will strike the Earth in the next 10 years. 10 years, that's nothing. Catastrophic event will strike the Earth in the next 10 years. As we know, that means that it's in this solar cycle. It goes on the solar cycle goes every 11 years. So they're talking about the end of this solar cycle, perhaps giving us a catastrophic Carrington-sized event impact. Now, according to space weather, Earth-directed solar flare, sprawling sunspot AR2965 exploded today, March 14, producing an M-2 class. So this is another one. It's not the one that was March 14. This is a new one that just exploded today. So it seems that they keep on increasing in intensity. What is an M2 class solar flare? Okay, the scientists classify solar flares according to X-ray brightness and wavelength, ranging 1 to 8 angstroms. 3 categories, X-class flares being the biggest. They are major events that can trigger planet-wide radio blackouts and long-distance radiation storms. M-class flares, this is what we're talking about here, are medium-sized. They can cause brief radio blackouts that affect Earth's polar regions. Minor radiation storms sometimes follow an M-class flare. Compared to X, the M-class events, C-class flares are small with few noticeable consequences here on Earth. So they're saying that this new one that exploded today, it usually takes 2 or 3 days to get to us, is an M2 class flare. The Earth-directed flare caused a minor shortwave radio blackout over Africa and Eastern Europe. Frequencies affected were almost below 15 megahertz. First look data suggests that the flare did not produce a significant CME. Stay tuned for updates, it says. And CME impact sparks bright lights. This is concerning the CME that left the sun on March 11. I'll leave links below for you for this on space weather for today, and also Express UK by Ian Randall. Please leave your comments, and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support, and that you find all my content so interesting. You'll find the Patreon account details in the description box below.